Hello, in this lecture we'll find out the area of a circle using two different methods. In the drawing we have a circle and we have also square ABCD. You know that this is 1/7 AP, this is equals to 1 unit in its length. This is 9/7 QC, this is equals to 4 units in its length. Again, our mission is to find out the area of this circle. So we'll start with the first method. And first of all, we know that all the angles inside the square are right angles. So those four angles, they are all right angles. So this is a right angle. This is also a right angle. This is a right angle. And this is a right angle. In the next step, we find the center of this circle. This point is point O. And we find the point of tendency of tangent AB with this circle. This point is point S. So here we join points O and S together by a straight line. OS is the radius of the circle. We define the radius of the circle as x, therefore OS equals to x according to our definition. So here we can implement rule 1. Repeat quickly rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also tangent AB, that is tangent to this circle is point M. Point M is the point of tendency of tangent AB with this circle. In addition, we have the radius OM that equals to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So we can actually implement rule 1 in our drawing. In our drawing, we have the radius OS that is equals to x. The radius OS is drawn to point S, that is the point of tendency of tangent AB in this circle. And whenever your radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. In the next step, we join points O and Q together by a straight line. So OQ is of course the radius of this circle, that is equals to x. Again, you can implement here rule 1. Why? Because we have the radius OQ that is equals to x. The radius OQ is drawn to point Q, that is the point of tendency of tangent BC in this circle. Whenever your radius is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So actually, inside quadrangle SOQB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral SOQB, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral SOQB as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle SOQB, side SO must be equal to the opposite side QB. But SO is x, therefore QB must be also equal to x. Likewise, according to the same rule, in the same rectangle SOQB, side OQ must be equal to the opposite side SB. But OQ equals to x, therefore SB must be also equal to x units in its length. So actually, we found out that quadrilateral SOQB is not a rectangle but a square. Why? Because of the fact that all of its sides are equal to each other. Each side of this square equals to x. So we also know that all the sides of any square are equal to each other. So in square ABCD, side AB equals to side BC equals to side CD equals to side DA. So side AB equals to side BC. So I write it down, side AB equals to side BC in square ABCD. AB equals to BC. AB equals to AS plus SB. Again, AB in total equals to AS plus SB. So now we know AB equals to AS plus SB. And it is equals to BC. BC equals to BQ plus QC. So in total, we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we will leave it as it is, plus SB. SB equals to X, and it is equals to BQ. BQ also equals to X, plus QC. QC equals to 3 units in its length, according to what is given in the question. So in total, according to equation 1, we found out that AS plus X equals to X plus 3. Here we subtract X from this equation, equation 1. So X will get cancelled. And we found out that AS equals to 3 units in its length. So we found out that this 9 segment AS is equal to 3 units in its length. In the next step, we will do a construction. That is to say, from this point P, we will draw perpendicular on SO. Again, from point P, we will draw perpendicular on the radius SO. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. So inside the small quadrilateral AP, we define the touching point of the perpendicular from point P and SO. This point is point N. So actually, inside the small quadrilateral APNS, we have 1, 2, 3 rectangles. This angle equals to 90 degrees according to rule 1. This angle equals to 90 degrees according to our construction, and this angle equals to 90 degrees because of the fact that ABCD is a rectangle. ABCD is a square, and all the sides, all the angles inside a square are right angles. So this is a right angle. So in total, inside quadrilateral APSN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this coefficient angle must be equal to 90 degrees in size. So inside the small quadrilateral APSN, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be this rectangle cut a square. So we relate to quadrilateral APSN as rectangle because it has 4 right angles. Okay, so this quadrilateral APSN is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So side A in rectangle AP and S, side AP must be equal to the opposite side NS. But AP is 1, therefore NS is must be also equal to 1. Likewise, according to the sum rule, in the same rectangle AP and S, side AS must be equal to the opposite side PN. But AS is 3, therefore PN must be also equal to 3 units in its length. So if we found out that inside quadrilateral APSN, PN equals to 3 units in its length and SN equals to 1 unit in its length. What is the length of this missing line segment ON or NO? From the drawings it is very easy to see that NO equals to SO, that is the radius of the circle that is X, minus SN. SO minus SN equals to NO. So NO equals to SO that is X minus NO that is 1. So in total NO equals to X minus 1 unit in its length. NO equals to X minus 1 unit in its length. In the next step we join points P and O together by straight line. Point O is the center of the circle, point P is the point of the circle itself, therefore PO is the radius of the circle that is equal to X. So in the next step, we'll copy the right angle P and O in a new page and we'll implement the Pythagoras theorem on this right angle, triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a relation for Pythagoras theorem. Okay, this is the right triangle P and O that they copied from the original drawing. According to the Pythagoras theorem, this right triangle P and O, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. So I write it down. PO squared, that is the square of the hypotenuse, is equal to Pn squared plus NO squared. PO is X, therefore PO squared is X squared, and it is equal to Pn squared. Pn is 3, therefore Pn squared is 3 squared, that is 9, plus NO squared. NO is X minus 1, therefore NO squared is X minus 1 squared. So in total we should find out that x squared equals to 9 plus x1 squared. So here we open the brackets on this side of the equation, of this expression, and we get that x squared equals to 9 plus x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2 times x times minus 2 times x times 1, that is minus 2x. So here we have x squared on both sides of the equation, so x squared will get cancelled. After we cancel x squared, on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, minus 2x. So in total we actually found out that 0 equals to 10 minus 2x. Here we add 2x to this equation, and we get that 2x equals to 10. Here we divide this equation by 2, and finally get that x equals to 10 over 2, that is 5. So we found out that the length of the hypotenuse AO, that is x is 5. X is also the radius of the circle, that is 5. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So the area of our circle must be equal to pi x squared. X is 5, therefore x squared is 5 squared, that is 25. So in total we should find out that we are looking for, that is the area of our circle, equals to 25 pi. In terms of numbers, it is equal to 78.54 square units. So repeat again, we actually found out that the area of this circle equals to either 25 pi square units, so in terms of numbers, the area of this circle equals to 78.54 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this circle according to the second method. So we know that ABCD is a square, therefore all of its angles are right angles. This is a right angle. This is a right angle. This is also a right angle. And finally, this is a right angle. We define the point of tendency of tangent AB with this circle. This point is point S. We define the center of the circle. This point is point O. In the next step, we focus on this common extreme point, point B. From this common extreme point, point B, we have two tangents to this circle, tangent BS and tangent BQ. And only all two, they are equal to each other. So, I take click on all two. According to rule 2, the lengths of two tangents from a common extreme point to a circle are equal. So in the moment we have a circle, this is the common extreme point, point P. From this common extreme point, point P, we have two tangents to the circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB. So can actually implement rule 2 in our drawing. Why? Because in our drawing, we have the common extreme point, point B. From the common extreme point, point B, we have two tangents to this circle, tangent BS and tangent BQ. And according to rule 2, they are equal to each other. That is to say, BS equals to BQ. So if we define, on, according to rule 2, Vs equals to Vq. So if we divide the length of this tangent Vs as x, then the length of this tangent Vq must be also equal to x because they are equal to each other according to rule 2. We know that ABCD is a square, therefore side AB must be equal to side BC. So I write it down. The square ABCD, side AB equals to side BC. AB, this is side AB, this is equals to AS plus SB. AB equals to AS plus SB. And AB equals to BC. BC equals to BQ plus QC. Again, BC equals to BQ plus QC. BC equals to BQ plus QC. So in total, according to equation 1, we found out that AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is, plus SB. SB equals to X. And it is equals to BQ. BQ also equals to X plus QC. QC equals to 3 units in its length, according to what is given as the question. So in total, according to equation 1, we actually found out that AS plus X equals to X plus 3. Here we subtract X from this equation, equation 1. So X will get cancelled, and we left only if AS is equals to 3 units in its length, according to equation 1. AS equals to 3 units. Okay. This is 9 segment AS. This is equals to 3 units in its length. In the next step, we'll extend line segment AD by straight line until it touches the circle. We'll define the touching point of the extended line segment AD with this circle. This point is point M. In the next step, we will focus on this common external point, point A. From this common external point, point A, we have tangent AS that is tangent to this circle at point S. In addition, from the same common external point, point A, if we draw a straight line, we can get here chord PN. So in total, from the same common external point, point A, we have tangent AS and chord PN. Therefore, we can implement here rule 10. So I'm clicking on rule 10. According to rule 10, rule 10 is true in any circle. So in any circle, if AB is a chord, AB is a chord in this circle, and PT is a tangent to the circle at point T. PT is tangent to the circle at point T. Then in this always the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can definitely implement rule 10 in our drawing. Why? Because in our drawing, we have, this is the common external point, point A. From this common external point, point A, we have tangent AS, that is tangent to this circle at point S. In addition, from the same common external point, point A, if we draw a straight line, we will get here chord PM. So actually, all the requirements of rule 10 are satisfied, and therefore we can implement a rule 10. According to rule 10, we get that AS square equals to AP times AM. Again, AS square equals to AP times AM. So I write it down. According to rule 10, if we focus on the common point A, according to rule 10, we get that AS square equals to PA, AS square equals to AP or PA, it is the same, times AM. Equals to PA times AM. AS is 3, therefore AS square is 3 squared, that is 9. So 9 equals to PA squared. PA is 1. PA times AM. AM in total, AM equals to AP plus PM. Again, AM in total equals to AP plus PM. So how to know? AM equals to AP plus PM. So in total, we should find out that according to rule 10, 9 equals to 1 times AP plus PM. So 9 equals to 1 times any number is 1, so we will know 1, so 9 equals to AP plus PM. AP plus PM. So 9 equals to AP. AP is 1 plus PM. Here we subtract 1 from this equation, and we get that PM equals to 9 minus 1, that is 8. So PM equals to 8 units in its length. That is to say, chord PM of this circle is equal to 8 units in its length. In the next step, we will do a construction. That is to say, from this point O, that is the center of the circle, we will draw perpendicular on chord PM. Again, from point O, that is the center of the circle, we will draw perpendicular on chord PM. So hopefully, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point N. So, actually, by doing this construction, we create a perpendicular ON that is drawn from the center of the circle, that is to say from point O, on chord PM. So, we drew perpendicular ON from the center of the circle on chord PM. And therefore we can implement the rule 11. So I'll click on rule 11. According to rule 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So in the moment we have a circle. Point O is the center of the circle. From point O, that is the center of the circle, we have here perpendicular OM on chord AB. Again, we have here perpendicular OM that is drawn from the center of the circle, that is to say from point O on chord AB. According to this rule 11, perpendicular OM bisects chord AB. If perpendicular OM bisects chord AB, it means that AM equals to MB. Again, according to this rule 11, the perpendicular OM that is drawn from the center of the circle, that is to say from this point O, the perpendicular OM bisects chord AB. That is to say AM equals to AB. Again, AM equals to MB. Okay, we can actually implement all 11 in our drawing. Why? Because in our drawing, from the center of this circle, that is to say, from this point O, we have perpendicular ON on chord PM. Again, from the center of this circle, that is point O, we have perpendicular ON on chord PM. So all the requirements of rule 11 are satisfied. Therefore, we can implement here rule 11. According to rule 11, the perpendicular ON bisect chord PM. Again, perpendicular ON bisect chord PM. That is to say, PN equals to NM. Okay, so according to rule 11, perpendicular ON bisect chord PM. That is to say, PN equals to NM. PN equals to NM. And perpendicular ON bisects chord PM into two halves. Each half must be equal to PM over 2. So the first half is PN that is equal to PM over 2, and the second half is NM that is also equal to PM over 2. So in total, according to rule 11, we actually found out that Pn equals to Nm equals to Pm over 2. But we have already found out that Pm equals to 8. So Pm over 2 is 8 over 2, that is 4. So in total, we actually found out that Pn equals to 4. From this equation, we know that Pn equals to 4. Okay, Pn equals to 4. So this is line 7 Pn, that equals to 4 units in its length. So in total, An equals to 1 plus 4, that is 5. In the next step, we join points O and S together by side line. S is the point of tendency of tangent AB with this circle. OS is of course the radius of the circle that is equal to x. So here we can implement rule 1, why? Because we have the radius OS that is drawn to point S, that is the point of tendency of tangent AB with this circle. That whenever you have radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside the quadrilateral ANOS, inside this quadrilateral we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral ANOS we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be less a rectangle if not a square. So we relate to quadrilateral ANOS as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ANOS, side AN must be equal to the opposite side OS. But AN equals to 4 plus 1, that is 5. Therefore OS must be also equal to 5. So OS that is equal to X, that is the radius of the circle, is equal to 5 units in its length. So if you found out that the radius of this circle, X equals to 5 units. The radius of the circle x equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle is equal to pi times the radius of the circle squared. Therefore, the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the radius of our circle must be equal to pi x squared. But we just write our formula that the radius x equals to 5. If x equals to 5, it means that x squared equals to 5 squared, that is 25. So in total, if we found out the area of this circle, that is the area that we are looking for in this question, equals to either 25 pi square units, so in terms of numbers, it is equal to 78.54 square units. So actually, in both methods, we found out that the area of this circle equals to either 78.54 square units or 25 pi square units. So in the next step, I'll summarize the lecture. We start with the first method, of course. In this lecture, we found out the area of this circle using two different methods. In the domain, we have a circle and we have also square ABCD. You know that line segment AB equals to 1 unit in its length. This is line segment QC, that is equals to 4 units in its length. Again, our mission is to find out the area of this circle. So first of all, we know that all the 4 angles inside square ABCD are right angles. So those 4 angles are all right angles. And we define the center of this angle, this point as point O. We define the point of tendency of tangent AB with this angle, this point as point S. In the next step, we join points O and S together by straight line. OS is the radius of the circle, that is equal to x according to our definition. The radius OS is drawn to point S, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. In the next step, we join points O and Q together by straight line. OQ is the radius of the circle that is equal to x. Again, because of the fact that the radius OQ that is equal to x is drawn to point Q, that is the point of tendency of tangent BC with this circle, then according to rule 1, tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to the same rule, rule 1. So inside quadrilateral OSBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its side. So inside quadrilateral OSBQ we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be the rectangle if not a square. So remember to quadrilateral OSBQ is a rectangle because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So in rectangle OSBQ, side OS must be equal to the opposite side BQ. But OS is x, therefore BQ must be also equal to x. Likewise, according to the same rule, the same rectangle OSBQ, side OQ must be equal to the opposite side BS. But OQ is x, therefore BS must be also equal to x units in its length. So if we found out that quadrilateral OSBQ is not a rectangle but a square, why? Because all of its sides are equal to each other. Each side of this square equals to x. Okay? So we know that all the sides of any square are equal to each other. That is to say, side AB equals to side BC equals to side DC equals to side DA. So AB equals to BC. In square ABCD, AB equals to BC. Repeat again, in square ABCD, side AB equals to side BC. AB equals to AS plus SB. Again, AB equals to AS plus SB, and it is equals to BC. BC equals to BQ plus QC. BC equals to BQ plus QC. So in total, AS plus SB equals to BQ plus QC. According to equation 1. AS is the missing side, so we leave it as it is. Plus SB. SB is X. And it is equals to BQ. BQ is also X plus QC. QC is 3. So in total, we should find out that AS plus X equals to X plus 3. Here, subtracted X from this equation, equation 1, so X will get cancelled, and we left only with AS that is equal to 3 units. So we should find out that this line segment AS equals to 3 units in its length. Okay. So in the next step, we did a construction. That is to say, from this point P, we do perpendicular on the radius SO. Again, from point P, we do perpendicular on the radius SO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SO. This point is point N. So inside quadrangle A, P, and S, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that states that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees inside. So inside quadrangle A, P, S, N, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be at this rectangle plus a square. So relate to the small quadrangle APSN is a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle APSN, side AP must be equal to the opposite side SN. But AP is 1, therefore SN must be also equal to 1. Likewise, according to the same rule, in the same rectangle APSN, side AS must be equal to the opposite side PN. But AS is 3, therefore PN must be also equal to 3 units in its length. Okay. What is the length of the missing line segment NO? NO equals to SO, that is X, radius of the circle X, minus SN, that is 1. So in total, NO equals to X minus 1 units in its length. In the next step, we join points P and O together by side line. PO is the radius of the circle that is equal to X. In the next step, I actually copied the right triangle P and O in the new page and implemented the Pythagoras theorem on this right triangle P and O. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle P and O that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle P and O, PO square, that is the square of the hypotenuse, equals to PN square plus NO square. PO is X, therefore PO square is X square, and it is equals to PN square. PN is 3, therefore PN square is 3 square, that is 9. Plus NO square. NO is X minus 1, therefore NO square is X minus 1 square. So in total, according to the Pythagoras theorem, we actually found out that X square equals to 9 plus X minus 1 squared. We open the brackets of this expression and actually found out that X square equals to 9 plus X minus 1 squared. X minus 1 squared equals to X squared plus 1 squared, that is 1, minus 2 times X times 1, that is minus 2X. So in total, we have X squared on both sides of the equation, so X squared will get cancelled. So on this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have 9 plus 1, that is 10, minus 2x. So in total we can find out that 0 equals to 10 minus 2x. Here we added 2x to this equation, equation 1. And finally found out that 2x equals to 10. Here we divided this equation by 2, and finally found out that x equals to 10 over 2, that is 5 units in its length. That is to say, the radius of this circle x equals to 5 units in its length. And again, the radius of this circle x equals to 5 units in its length. Our mission is to find out the area of this circle. Actually, the area of any circle equals to pi times the radius of the circle squared, and therefore the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, therefore the radius squared is x squared. So in total, the area of our circle equals to pi x squared. X is 5, therefore x squared is 5 squared, that is 25. So in total, we shall find out that the area of this circle, that is the area that we are looking for, equals to either 25 pi, or in terms of numbers, the area of this circle equals to 78.54 square meters. We finish with the first method. In the next step, I present to you how to find out the area of this circle according to the second method. So first of all, you know that ABCD is a square, therefore all those four angles are right angles. We define the center of this circle, this point is point O. We define the point of tendency of tangent AB with this circle, this point is point S. The next step, we focused on this point B. Point B is the common sum point in relation to this circle. From the common sum point B, we have two tangents to the circle, tangent BS and tangent BQ. According to all two, they are equal to each other. That is to say, BQ equals to VS. VS equals to BQ according to all two. If we define the ref of VS as x, then BQ must be also equal to x because they are equal to each other. You know that all the sides of square ABCD are equal to each other. That is to say, side AB equals to side BC equals to side DC equals to side DA. And especially side AB equals to side BC. So now again ABCD, side AB equals to side BC. Side AB equals to AS plus SB. AB equals to AS plus SB. And AB equals to BC. BC equals to BQ plus QC. BC equals to BQ plus QC. So in total, AS, according to equation 1, AS plus SB equals to BQ plus QC. AS is the missing side, so we leave it as it is. So AS plus SB. SB is X. SB is X. And it is equals to BQ. BQ is also X. BQ is X plus QC. QC is 3. So in total, we found out that AS plus X equals to X plus 3. Here we substituted S for this equation 1, and finally found out that AS equals to 3. AS equals to 3 in its name. Okay. In the next step, we extended line segment AD by straight line until it touches the circle. We define the touching point of the extended side AD with this circle. This point is point D. Then we focus on this common extent point A. From this common extent point A, we have tangent AS and tangent. We have tangent AS and we have. If we do a straight line from this common extent point A, we get here chord PL. So actually, all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, AS square equals to AP times AM. Again, AS square equals to AP times AM. So if you follow on the common sum point A, according to rule 10, AS square equals to PA times AM. PA is 1 times AM. AM equals to AP or PA plus PM. Again, AM equals to AP plus PM. So in total, 9 equals to 1 times AP plus PM. AP is 1. So 9 equals to AP plus PM. AP is 1, so 9 equals to 1 plus PM. Here we substitute 1 for this equation and find out that PM equals to 9 minus 1, that is 8. So PM called PM equals to 8 units in its length. In the next step, we did the construction, which is to say, from this point O, that is the center of the circle, we do perpendicular on chord PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and chord PM. This point is point N. So now we can implement rule 11 in our drawing. Now from the center of the circle, that is to say from point O, we do perpendicular on chord PM. And therefore all the requirements of rule 11 are satisfied, and therefore we can implement rule 11. According to rule 11, the perpendicular ON bisects chord PM. Again, perpendicular ON bisects chord PM. That is to say, if perpendicular ON bisects chord PM, it means that PN equals to NN. So according to rule 11, PN equals to NN. And the perpendicular ON bisects chord PM into two halves. Each half must be equal to PM over 2. But PM is 8, therefore PM over 2 is 8 over 2, that is 4. So in total, from this normal equation, we derive that Pn equals to 4. Pn equals to 4. So this is line segment Pn is equals to 4 units in itself according to rule 11. In total, An equals to AP plus Pn. That is to say, it is 1 plus 4, that is 5. In the next step, we join points O and S together by straight line. OS is the radius of the circle, that is equals to X according to our definition. The radius OS is drawn to point S, that is the point of tendency, or tangent AB with this circle. Whenever radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius SO. If AB is perpendicular to SO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So, inside quadrangle ANOS, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to our construction. This angle equals to 90 degrees because ABCD is a square, and this angle equals to 90 degrees according to rule 1. So, in total, inside quadrangle ANOS, we have 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees inside. So inside quadrangle OSAN, we have 4 right angles. And according to rule 5, any quadrangle that has 4 right angles must be this rectangle if not a square. Okay? Hello? Hello? Who is talking? I'm in the middle of the Zoom lesson. Try to call you in 10 minutes. Okay? So inside quadrangle ON S A, we have 1, 2, 3, 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this rectangle, not a square. So we write to quadrangle ON OS as rectangle because it has 4 right angles. But we also know that the opposite sides of the rectangle are equal to each other. So in rectangle ON AS, side OS must be equal to the opposite side AN. But AN equals to 4 plus 1, that is 5. Therefore OS must be also equal to 5 units in itself. OS equals to X, and X is the radius of the circle. Therefore the radius of the circle equals to 5 units in its length. Our mission is to find out the area of this circle. Okay? The area of any circle equals to pi times the radius of the circle squared. So the area of any circle equals to pi times the radius of the circle squared. So it is the area of our circle must be equal to pi times the radius of our circle squared. The radius of our circle is x, so the area of our circle must be equal to pi times x squared. X is 5, therefore s squared is 5 squared. That is actually 25 pi. So in conclusion, we actually found out that the area of this circle in both methods, it is equal to either 25 pi square units, or in terms of numbers, it is equal to 78.54 square units. Okay, thank you very much.